Let's continue looking at probability as we get into lesson 12.2, chocolate versus vanilla. In this lesson, we're going to continue what we talked about with tree diagrams and examining conditional probability. And we'll do that using multiple representations. So as we did the tree diagrams, we'll also get into two-way frequency tables and those Venn diagrams that we worked with in the last lesson. So the task for today is chocolate versus vanilla. I'll read through it. It says Danielle loves chocolate ice cream much more than vanilla. It was explained to her best friend Raquel that so does most of the world. Raquel disagreed and thought vanilla is much better. To settle the argument, they created an online survey asking people to choose their favorite ice cream flavor between chocolate and vanilla. After completing the survey, the following results came back. There were 8,756 females and 6,010 males who responded. Out of the males, 59.7% chose vanilla over chocolate, and 4,732 females chose chocolate. So based off of that data, what's your first impression? Which flavor do you think won? Which one is the favorite? So choose chocolate or vanilla. Then write a short sentence describing what you see at first glance that makes you think this. So after we do that, we're going to break apart the information. We're going to organize it based off of a two-way table using counts, not percentages. So how many females chose chocolate? How many females chose vanilla? Same with males. We'll organize the data in a Venn diagram, chocolate, and this is female. And then we'll also take a look at it on a tree diagram. So how many were female? How many of those females chose chocolate? How many chose vanilla? Chocolate given they were female. Vanilla given female. How many males? How many male given they're male chose chocolate? Given a male chose vanilla. So try organizing that data, and when you're ready to take a look at that, you can restart the video and see how I set it up. So pause it now and work through questions 1 through 3. Okay, so we're able to represent the data in 3 different ways based off the given information that we had up here. So they were given 8,756 females and 6,010 males. Out of those males, 59.7% chose vanilla. So 59% of the 6,000, which is 3,590, which left 2,420 left over. We know 4,732 females chose chocolate, means that left 4,024 that chose vanilla. If we add up the totals, we see how many chose vanilla and how many chose chocolate, and how many total were surveyed. We can organize based on the Venn diagram. Here, this is people who chose chocolate. So, and this is females. So the middle would be females who chose chocolate, which we can see is 4,732, which means this would be females who did not choose chocolate. This would be, they would not be females in this section. So the males who chose chocolate, which would leave people who did not choose chocolate and were not female, would be those vanilla males, 3,590. Then looking at the tree diagram, I'll zoom in a little bit so it's easier to see. We've got females and males. Of the females, how many chose chocolate, how many chose vanilla? Of the males, how many chose chocolate and how many chose vanilla? So numbers all match up together, but they're all helpful in their own way in seeing different bits of information. So what we need to do on the next page is look at that organized data and write probabilities that help support our claim regarding the preferred flavor of ice cream. So for each probability, write a complete statement as well as corresponding probability notation. So we can say the probability of choosing vanilla is, or the probability of choosing vanilla given that it's a female. And we can list all those out. So after we do that, you want to look over your representations and find out which ones are easier to see. So maybe as you're going through here, which of these are easier to find? Can I find the probability of just vanilla easily on the tree diagram, two-way table, or Venn diagram? Maybe which ones are easier to find, and you mark those as you go through there. And then going back to the ice cream, do you think there's enough information to proclaim the statement that one ice cream is favored over another? And give an explanation. So pause the video, come up with some probabilities, and restart it once you're ready to see probabilities that I came up with. So these are some of the probabilities I came up with. Probability of someone choosing vanilla was 7,614 out of 14,766. These are all listed as fractions. I could have listed them as percentages as well, or simplified fractions, or even decimals. But you can take a look at them and you determine maybe which ones were easier to see. So taking a look at some of these, maybe you had some more, but which ones are easy to see on the tree diagram? Well, tree diagram, I think it was easy to tell, these, well, females, what's probably a females? You can quickly see that information. And another thing that was easier to see, I should say, were these conditional probabilities. How many chose chocolate given that they were female? Chocolate, 4,732 out of 8,756. Same with the males. So it's easy to compare those. Two-way table, it's grouped in that manner that we can compare. Out of chocolate, how many chose chocolate were female? Well, 4,732 out of 7,152. So that would be the probability of, female, given that they chose chocolate. And that was one of those that I hadn't listed up there before. But the two-way table helps those, it's easier to see those. Or we're just comparing out of females, given that they're female, how many chose vanilla, or how many chose chocolate, or overall, what's the probability that a female chose vanilla? So that's easier to see in that one. The Venn diagram, that one takes a little bit to learn how to use, but we're comparing two different variables, chocolate and female, so it's easier to see, well, how many are female that chose chocolate, or how many are female that didn't choose chocolate, or how many chose chocolate that aren't female, or how many are not female and didn't choose chocolate. So it's easier to see those probabilities in that one. It's harder to compare, how many total females are there, or how many total males are there. You got to kind of interpret, well, where's the males? Not in the female circle. So males would be these two values. So it gets a little bit harder to see on that Venn diagram, but the tree diagrams and two-way tables kind of make it pretty clear how many of each there are. You can quickly see how many chose chocolate, how many chose vanilla, these two. So each have their own advantages and disadvantages. I'll let you fill that in how you see fit. Then getting back to the ice cream, do you think there's enough information to proclaim a statement that one ice cream is favored over another? We'd say that overall, vanilla is the most popular flavor. It's just over 50%, and the males chose it 59%, and it's more females chose chocolate, but overall, we'd say that vanilla is the favorite one. And since there were 14,000 people that took it, it's a pretty large survey. It's not just, I asked 10 friends and see which one they like. But we have pretty good data. The law of large numbers says, the bigger the sample, the better, the more valid the results are. So we'd say this is a pretty confident survey. We could be pretty confident that vanilla is the more favorite in this case. So, dealing with, things can be random. You flip a coin 10 times and you could get 7 heads. But, if you did it 10,000 times, it would be very close to 50%. So why don't you try that? Flip a coin 10,000 times and see how close you get. It should be pretty close to 50% if you try it, and if you have the time for it. So, but that's the law of large numbers. The more it happens, the closer it is to what it's actually supposed to be. So in your work in class, you'll work on analyzing Venn diagrams some more. You'll also work on writing conditional statements from a two-way table, and then finishing up working on fractions and percents, since there's a lot of that in our probabilities. So you can work on that in class. If you have questions on this or stuff we talked about in the video, be sure to ask in class.